Well, let's try to answer this question together. It was taken on November paper 1 2016, the grade 10 one. Now, the graph of f, which is the parabola, and of g, which is a straight line, are sketched below. A and B are the x-intercept of f. A and B are the x-intercept of f, which means around on x-intercept we know that y is equal to 0. Then C and D are the y-intercept of f respectively and of g. Then which means C is the y-intercept of f and D is the y-intercept of g. Now K is the point on G such that BK, which is BK, is parallel to is supposed to be parallel to y-axis. Is parallel to y-axis. BK is parallel to y-axis. Then F and G intersect at A and E. So this graph of a straight line and the parabola, they intersect at this point and at this point. So they intersect twice. Now, that is the information that we have, ladies and gentlemen. Now, question number 1, uyasibuza ukuba what are the coordinates of C? The coordinates of C, will remember that C is the y-intercept of this graph of f. So when we are looking for the coordinates of C, we'll have to use the function of C, which is the equation of C, of ff, which is this one, f at x. Now, when x is equal to 0 there, you will definitely get -4 because we have f of 0, which is y-intercept. We know that we have 0, so -4, so you will always get -4. So the value of y at C is really -4. So the coordinates of C is 0 is to -4. Now, on the intercepts, on the x and y intercept, you must know that one of the variable is equal to 0. So it depends whether it's y-intercept where x is equal to 0 or it's x-intercept where y is equal to 0. So it's easy to find or to figure out the values of the intercept. Now, this is our C. Then let's find the coordinates of D. The coordinates of D, you can see that D lies on the straight line, so we'll have to use the equation of a straight line to determine the coordinates of D, because D is found on the straight line, not on F. Now the coordinates of D, you know that this is y-intercept where x is equal to 0. So we know that the x coordinate there is equal to 0. Then the y coordinate will be your constant value, which is 2. So the value of D now is, the coordinates of D is now equal to 0 is to 2. So we are down with number 2 as well. Now let's come to the length of CD. The length of CD, which means the distance between, or the distance between these 2 points, which is this length. So when the line is vertically put, you can just say the y maximum minus y minimum to get the distance between these 2 points that are on top of each other. So which means the distance of CD will be 2 minus -4, which is gonna be 6 units. So this is how you determine the distance between 2 points that are in an horizontal or in a vertical line. So you say this line, this number minus this number, then you get the distance. So you just don't have to forget about the other negative sign. So we have calculated this one, which is equal to 6 units. Now let's determine what? Let's determine the coordinates of B. The coordinates of B is found on the graph of F. The graph of F, we are going to use it to determine the coordinates of B. And we know at B, we know that y is equal to 0 because exactly y is equal to 0 there because b is at the x-intercept. Now in our function we are having f of x is equal to x squared minus 4. Then we have to put 0 in the place of y to find the coordinates of b. Now in the place of y we put 0, then we have x squared minus 4. Then what we do, then we can just factorize our equation to get these two different values. Then our x is equal to 2 or x is equal to negative 2. So we have these two values, 2 and x is equal to negative 2. So we are having that one. So on that note, the coordinates of b, it has to take the negative value and is to 0. And of course it also gave us the coordinates of a, which is 2 is to 0 because the other 2 must correspond with the other intercept, x-intercept, which is a in this case. So we have now calculated the coordinates of b using the graph of f, because when you see that b is on the graph of f, then you will have to use the equation f to find the missing variable. Now let's go to what? Let's go to number 5. Number 5 says calculate E, which is the point of intersection of G and F. Now you can see that we are calculating this point, and you can see that both of these graphs, they are equal in that point. So we really need to know the fact that they are equal, these two equations, and we know that they are equal here and also at a. So we just have to know that at e and at a, f at x is equal to g at x, because this is the point of intersection of this graph anyway. Now, what is f at x? F at x is given as x squared minus 4, which means we are having x squared minus 4. Then it must also be equal to, the graph of g is negative x plus 2, which is this one. Then in the place of g, we put minus x plus 2. So the idea is to equate these two equations because we are looking for the point of intersection. Now let's solve the value of x. Now the value of x is going to be, let's collect the like terms. We'll be having plus x, then therefore minus 6, yes, then is equal to 0. When we transpose everything to the left side, then we are going to factorize and see what you call, we are having 3 is to 2, then 3 is positive, then 2 is negative. Then of course we have x equal to 2 or x is equal to negative 3, and they are equal at here at a, and we can see that the x coordinate of a is right at 2, and the x coordinate, the other x coordinate is right at e, that we can assume that we have negative 3, which is this one is to the value of y. But now they want the coordinates of e, which means they also want the value of y right here. So we need to use any of these points to substitute 3 at, which means you are having f at negative, g at a negative 3, so that you find the corresponding y value there. So we have negative 3, then plus 2, so the answer is just going to be 5. So we are having is to 5 as the y value of e. Now we are done, and we have seen how do we calculate the coordinates at the point of intersection. Now done with everything else, let me just rub all what I wrote here. Then let's go to the next question. The next question is 5.6. 5.6 requires us to calculate or to find the values of x at which f at x is less than g at x. F at x is less than g at x, where we can see that f at x, let me wrap some of the things that you might not need currently. F at x is this graph, and we can see that this graph of before x is equal to 3 is right above g, which means f is above g before -3. Then you can see that g at x is this one, and you can see that it is above this graph. It is above f at x right after -3. Then you just need to note one thing here, because the graph will confuse you the most, especially if you don't take note of what is required. Then upper, you can see that the x coordinate at E is -3. Then you can just write your points, and you might not need the y value. Then the idea is to know that the graph becomes bigger than the other one at the point of their intersection. So we just need to draw the vertical lines that are going to cut their intersection like this. And we know that here we are having just two. Then what you notice is that this is f at x. F at x is greater. You can just put your positive. F at x is greater here than g at x, and g at x is less than f at x. Doesn't mean that it's negative. When I put that number, I'm just indicating that g at x is less than f at x before 3. And what is the question? First of all, f at x, we are looking for the values of x where f at x is below g at x. F at x found itself being below g at x right after -3. You can see that f at x is below this graph. F at x is below this graph. F at x is still below, still below, still below, still below. Yes, so which means we are looking for this interval. This is the interval where f at x is below g at x, because right after -3 you can see that f is going below g at x, going below and up and at 2 as well. Now we are going to answer the question that, okay, x is an element, it starts from just after -3, then but below 2, because at -3 the graphs are equal, but after 8 you can see that your graph of f is really negative. Not negative exactly, but it's below g at x, because you can see that g at x is right there. Let me just use the g at x is right there, and f at x is right below g at x, just like that. So this is our interval. The interval of x where this condition happens, it's between -3 and 2. So that is why we just have this analysis. So coming to f at x times g at x being greater or equal to 0. Now let me wrap some of the things that you might not need, so that we get everything cleared up. Now we are having f at x times g at x being greater or equal to 0. Where is f at x? F at x is this one. F at x is this one. Then g at x is this one. Now we are going to mark the x-intercepts. X-intercepts of the very same graphs, they are going to tell us what we need. So at x-intercept, we know that we can take this line. We can also take this line. Now you can see that when we talk about f at x times g at x is greater or equal to 0, we mean like these two graphs. Like for example, if you have 2 times 2, you get something that is greater than 0. And if you have -2 times negative 2, you also get something that is greater than 0. So that means when you have same signs and you're finding the product of two things, you will always get something that is greater than 0. Otherwise, if the signs are different, then the sign then then the sign is gonna be negative for the product of those two things. So we now are going to focus on where f at x and g at x are having the same, what you call, the same sign. So having this kind of situation, let me just have this one. F at x, g at x is positive here. G at x is positive, and the line that is positive is the line that is above x-axis. Then g at x is negative, right below the x-axis. Then coming to something else. Coming to f at x. F at x is above f at x, and it is found positive up until we meet ux, up, because upper is going to be below the x-axis and the sign of g of f is going to be negative. But after that too, it becomes positive again. So it is wise to write to write these lines, because these lines, they show or they tell you the boundaries where you have to conclude about your intervals. Now, what are we having? We have positive times positive, which is going to give us something that is greater than 0. So on that note, we are having, and here we are having negative 2. Remember, let me just use a different line or the different color. We have negative 2, and here we are having positive 2. So you can see that before negative 2, everything was positive. Everything was positive, which means f at x times g at x, it gives you positive right on this side. This is positive and we like it. Then what happens after negative 2? After negative 2, you can see that this graph is negative and this one is positive. And positive times negative gives you negative, and upper we have negative, hence here we have positive. Then after 2, which is this side, you can see that we are having f at x being positive and g at x being negative. So positive times negative becomes negative. So which means this line tells you that after 2, everything becomes negative. So that means we want t. Now we want the values of x where the product of these two functions give us a positive, because once you have greater or equal to 0, we are talking about a positive value. Now the positive value is only found right on this interval, which is before negative 2. So how do you then write that? So x is an element, then from negative infinity then to 2. So this is what we have. Then we have to have an enclosed brackets because of this equal sign as well. So this is the value that help us to know that the product of these two functions at this interval gives us a positive sign. Coming to what? Coming to the length of AK. AK, can I rub everything so that it becomes clear to everyone? AK, where is AK? AK is, this is A, this is A, this is K. So if you want the length of these two things, you will probably use the distance formula. And the distance formula requires you to know the x value, then the y value, the x value, then the y value. So the length of AK or KA is going to be equal to square root of what is x1. Let's have negative 3. then x2 is -2, then all squared, then plus, then y1 is 5, then -0, then you have that. So whatever that you get up, remember you have what? You have 5 squared, which is 25, then plus 5 squared, which is another 25. Then your answer is gonna be square root 50, which is fine. So this is gonna be the length of your what? Of your AK. You will probably write it in a what? In a simplest set form, which is 25 times root 2, which is gonna be 5 root 2. Yes, square root 50 is 5 root 2. Now this is just what we have, and I think you have enjoyed the unpacking of this on how to answer questions of this nature, and especially in this position you will probably want to get more explanation. You can repeat the video and do whatever you want until you understand what is required into a question. Otherwise, I tried my best, and see you right on the next video.